Hello there, my name is Suvasis. In new series, I'm going to talk about how you build a highly scalable indexer for Elasticsearch, and that is also multi-tenanted. So what it means is you have a cloud application, let's say, with several tenants. Every tenant will have their respective database, and there are a lot of entities for which you have a lot of data in the tenant-specific database that you want to index into Elasticsearch to make it searchable. At the same time, this component which will do the indexing has to be horizontally scalable. How do you enable horizontal scaling in this component, right? That is going to be interesting to see. The major components that I'm going to showcase in this particular series of videos is going to have Elasticsearch at the core. Then you'll have some RDBMS from which you are sourcing the data and then indexing into Elasticsearch. For real-time events, I'll be using Kafka, right? And then for making it horizontally scalable, making it a distributed component, I'll be using Zookeeper. All right. So those are going to be the major tech stack. In this first video, I'm going to introduce you to this project that I have uploaded and then running it from outside, not really going through the code, but running it from outside and showcasing its capabilities. And next video onwards, I'm going to showcase piece by piece. Let's say the very first component is the indexing itself, right? Wherein we'll read the data from database and then you will index into Elasticsearch. So I'll probably start with that and then I'll move towards real-time indexing, where your application is producing a lot of events, real-time events, which are captured in Kafka. Kafka is one of the example message bars that you'll see that I have implemented in this project. But feel free to choose your own favorite message bar, like Rabbit MP or anything. There are plenty of choices these days. So feel free to make your choice. And the third video probably I'll go towards, okay, now you can run standalone this particular indexer component. But let's say the amount of documents that you have to index in Elasticsearch is going to be huge for your project. In that case, how do you make the same component distributed? It will have distributed capabilities, which means you can have multiple components joining into a cluster, right? And then contributing to the overall load of indexing. Right? It might be coming from several tenants at the same time, and then you capture them as an event in Kafka, in this case, the message bus. And from there, how Zookeeper will create different tasks for different workers, right? Worker is nothing but another instance of this indexer component, right? So one instance will be working as a server, or not really server, I was the master, sorry. And then rest of the components, same components you are instantiating either in the same system or in a different system, they'll be joining as workers. If the master dies for whatever reason, or you just for the sake of this demonstration, you kill the master deliberately, and some workers from the pool will be electing it as a master, and it will take up the responsibilities of a master. So what are the responsibilities of a master? It is going to take those real-time indexing requests as a task, and then master will allocate them to individual workers. That is where I'm going to use heavily Zookeeper. So that would be my third or fourth video based on how much lengthy it is becoming the video. I don't want too lengthy videos. All right, with that, let me share my screen and talk about the repository first thing. If you look at my screen, Elasticsearch indexes, that is the component that I'm going to detail in a series of videos going forward. So it has, like any other simple Maven based Java project, SRC and then all the configs are under this config folder, right? You can see DB, which will have database related configuration. You'll have Elasticsearch configuration, indexer related mapping, Elasticsearch mapping, message bus. These are first templates in Elasticsearch, Mustasbase, and then you have multiple tenants configuration here and Zookeeper. All right. In today's session, I'll not really take you through the code, but basically, how are you going to be able to run this code? I think I have added a very simple README as of now. So once you build this project from within Eclipse, after you take it out from here, build it from Eclipse ID. Once you have the jar created, you can run it like this. You can see I have put two commands. One is running in simple client mode. The second one is running in service mode. That's the distributed or the horizontal scalable part of it. So you can run it as a service also. In that case, it will go for the master collection. It will go for having worker joining this cluster, so on and so forth. The first thing that I'll do is I've already kind of taken the same code here and then I'm not sure if I'm sharing my screen here. So let me share. So let me share the ID. And here you can see I've checked out the code from GitHub repository. And you can see a bunch of config folders and respective config files within each of those folders. I just started building the code. This is how you do it. You can see run configuration, or you can click first time on the Maven build or Maven build 3 dots, and it will let you select your run configuration. So in the run configuration, I put clean space install. You can see Elasticsearch indexer. This is Maven build, and put two goals. First, we will clean the project and then clean the target directory, and then it will start building the code. As simple as that. I just invoked that and I've got the project built successfully. Then you'll have to open this configuration files and then modify database related configuration. You have to open Elasticsearch configuration file, indexer configuration file, and likewise, right? So let me quickly show you index -config .xml. There you can see what I'm going to do is parent index. I've mentioned that this is my parent index. We'll talk about batch count, which is like how many documents that you are sending per request for Elasticsearch to receive, right? So in a single batch, it will send maximum 100 documents. Multi-threaded, true or false. So if you want to do the indexing with multiple threads, then you can turn it on, saying update that's true, and then delete records after indexing. It's basically, should I delete the records or not? I think as of now, I'm not sure if I'm honoring this. So barring this, keeping this aside, rest of the configurations are important. And then this is index definition, name equals to student, that is the index name. And then query db type equals to MySQL. So I'm going to read it from MySQL. You can probably see it here. I'm going to read students, this students records. These are my different students records here. So I'll select student ID, name, age, roll number, sex, religion, nationality, parent name, date created, last updated from students, some while condition, dummy condition. Put it in CData, so it will be taken as literal text without interpreting a different document type equals to student, ID key equals to student ID. This one modified date column is last updated. I think I don't have any custom mapping in this particular example, but probably I can introduce you to custom mapping also. Like let's say I have in one field, I have comma separated values. And then I want to convert that into some other format, right? So that custom mapping would help us providing any sort of custom mapping on which you can specify on this column. This is the class implementation for that custom mapping, right? I'll show that in a separate video. And skip index creation false. Yes. Log space configuration not really required for today's demo. Mapping. Okay, students index mapping you can see. So it should be in line with the query that you're generating. Student ID, name, age, roll number, and you can map it here. Student ID, name, age, roll number, etc. All right. So if it is text, that means it is analyzed. Okay. All right. Next, I've talked about this. You have message bar, basically Kafka related configuration. I'm running in my local system, so you might see some configuration pointing to the local system. Ignore the rapid MQ configuration. Look at this Kafka message configuration, message bus, real-time queue. That is the name of the queue. Kafka is running in localhost 9094. Okay, these are your search template. You can ignore for now. Tenants, tenant related configuration will be here. It has some actual database information, so I'll not go there, but you can edit. Those are self-explanatory configuration file, and then at the end you have Zookeeper configuration file. Again, Zookeeper is also running in my local 21814. Node ID I have given for current process. I can change it to maybe 1, and for any subsequent process that I have run, right? So as I said, this is horizontally scalable. So if I run another instance of indexer, then I'll give it maybe 2 or 3 in that order, right? And this is similar to how Kafka uses Zookeeper. So every time you instantiate a broker, then you'll have to have a different ID for that, right? Similar on the similar line, I'm saying node ID is your unique ID for every single instance of the indexer component that you run. And some of the path election, this is basically path in Zookeeper. So this is the path in which I'll keep election related information. This is the path where I'll keep, so this is basically process not prefix, P underscore. Master can work true or false. So if master can work is false, it will be working only as leader. So whatever responsibilities that you've allocated for the leader, it will perform only that. If you say master can work as true, that means master can perform both the roles, like whatever it is doing as a leader, and it is also going to perform as a worker. It will execute all the workers' duties also, right? All right, that's pretty much it on the configuration side. Let me run this code. Okay, just give me a second. So expand this and say this is the startup class here. So you can say run as Java application. I'll show you what parameters I'm arguments I'm passing. Let it run. I'll come back to the output and explain what it is doing. In the meantime, you can see in the arguments I'm passing -3 Elasticsearch util home / config minus operation type OP is full indexing minus service false. So it is not running as a service mode. It is basically one single instance of the indexer component that you are running. Once it has indexed everything based on this operation type, like full indexing, I'll explain that what it is. It will come out, right? So it will not keep on running because you are not running this as a service, right? False. Okay, I'm referring one environment variable, which is basically the root path of this project, so that from there I can refer the path of the config folder, which I've already explained. Minus OP full is there are three kind of indexing this particular component is supporting. One is full, one is incremental, and another is selective or real time. So full indexing is let's say you have a legacy application and it has all of your data in relational database, and that you want to make it searchable. So you want to take the entire set of data that is there or entire table that is there in the relational database, and then it will do a full indexing. Incremental is, let's say your application is not event based, so not entire application is event based, or not not a single part of the application is event based. It can be in different scenario. In any case, if those events are not there, how do you make sure whatever new entities that has been created in the database or any existing entities which are updated with some additional value in their different columns? So create, update, and delete also. So how do you keep Elasticsearch up to date with those changes that is coming into your database? And if there are no application events, then you can't even uh, take action against those events. So that means you have to rely on database. And then here you say incremental instead of full, it's incremental. And what that means is it will take incremental records only from the previous checkpoint to this checkpoint, and then it will do indexing of the new or updated documents which have come to the database. Minus of p equals to uh, selective is you want to do real-time indexing. So as in when the event comes, you want to run it in that mode. So if you're running it in standalone mode, uh, it I mean you can still manage to work it, like you can subscribe to the Kafka message bus and then wait in an event loop for any new events to come. As in when it comes, you can index that document. Minus service false or true, right? So minus service false, by default it will run in standalone mode. The moment execution finishes, it is done, right? So, but if I say minus service true, that means it will continuously run an event loop and it will look for new events. Okay, if time permits, I'll show both of them. Alright, first things first. So let me show you the log because I've already executed. So you can see there are total of 338 records that it has found. You can tally it from your database table also. It is really so, yes, 338 documents it has received. And with a batch per batch, of 100 documents, it will take 4 batches, right? 100, 100, 100, and then last batch will have only 30. So yeah, you can see current batch number 1 by 4, 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, and it's done. All right. That's about the full indexing. The next thing I would show is the service mode, right? Again, once you have built the job, you can run it this way as well, right? Up to you how you want to run it. Here I'm running from Elasticsearch. So, sorry, I'm running from Eclipse just for the convenience. Okay, so I'll say true, apply, run, and let's see what varies from the previous run to this run. Okay, you can see process ID 1. That's what we gave, right? Node ID is 1, and then I'm the new leader. So because there is only one process, it has elected as the leader. If I run another instance of it, then the second one will join as a worker. Let me give it a try. All right, so what I'm going to do is I've already built the code, and it's where I am. So I've copied the two things, like the target and config. These two folders from my build location. In fact, let me show you the build location also. You go here, and then you go to inside, you can see target and config. So those are the two things that I've copied into a different folder called index2 config and target. Okay, with this, what I'm going to do is go to terminal, and then I'll set this new path as a Elasticsearch util home. So that is the new home because I'm in a new folder and different location, right? Index2, and I want to instantiate the indexer instance from here. For that, I'll just copy the command that I have posted here, and I'm running it in service mode, right? So I'll say service equals to true, and I don't know whether this is going to be the reader or this is going to be the worker here, right? Now, one thing that I know is here I've already run first instance, so it is already having a leader, process one. What happens to this? Before even this, there is one file that I have modified. So if you see the node ID in this config file, right, zookeeper config file, so I marked the node ID as 2. That means the second process would be starting with a process ID of 2. If I keep this as 1, let's give it a try. Now there would be some conflicts, right? Because you have one process which is running already with that ID. Now, if you run it, process ID 1 has started. That is strange. Okay. I look into this. Ideally, it should not have been the case because same process ID should not have multiple instances running. Okay. I'll go back to my previous state of it. And rerun it. Let's get the terminal. So this time process ID 2 and setting watch on node with path underscore 00001. Alright, so you have two processes running, but it doesn't matter. The use case that I'm going to show is okay. I want to do I'm doing real-time indexing because it is waiting for new events, my real-time indexer. And here I've run a Kafka command, Kafka console produces. I'm going to produce new messages, right? So for that, copy paste this workload. I'll explain that. So basically, I'm saying to my real-time indexing, this is your tenant ID, tenant one. Object code is student, basically the document type. Operation type is create. You are going to create a new document in Elasticsearch by querying your whatever is the corresponding database table. And the ID is true. That means the new document that has come to database, the new record, it ID 2, that has not been indexed in Elasticsearch. That's the assumption. And with this payload, it is going to do that indexing. You can see that request has come, zookeeper has taken that task and then given it to the worker. Right? And you can see fetching data connected to slice tenant one, and then the query that is being run to fetch the data for that particular student, which is ID 2. You can see student 2. Okay. And that's how the real-time indexing is working. So I've shown you full indexing. I'm showing you real-time indexing, and that's where I'll stop. Next topic would be basically how I interfacing with Elasticsearch for the indexing, right? So I'll take you through the code. Thank you.